Borealis, more commonly known as the Northern Lights, paints the sky with stunning shades of green, red, and purple, and sometimes even more. But why does this happen? Let's explore. The Northern Lights appear when charged particles from the sun, carried by the solar wind, reach Earth and collide with gases high in the atmosphere. The colors depend on which gas is hit and at what height. For instance, oxygen glows green or red, while nitrogen shows purple and blue. And that's why no two auroras ever look the same. They are shaped by the invisible dance between the sun and the Earth's atmosphere. Auroras aren't unique to Earth. Jupiter and Saturn also have them, though often in ultraviolet, which makes it invisible to our eyes. Here on Earth, we see them in the northern hemisphere as the Aurora Borealis, and in the southern hemisphere as the Aurora Australis, the same phenomenon from the opposite pole. Scientists study auroras with satellites, ground-based cameras, and radars to track where and when they appear, their brightness, and their colors. This helps us understand the Sun-Earth connection, our magnetic field, and how solar storms affect, for example, satellites and power grids. Then there's Steve. Steve stands for Strong Thermal Emission Velocity Enhancement, and it looks like an aurora but forms differently. It appears as a narrow purple arc, sometimes with green picket fence stripes. It is caused by fast-moving streams of hot gas in Earth's upper atmosphere. Steve often shows up alongside auroras just south of the main aurora zones in places like southern Canada, southern Alaska, northern Europe, New Zealand, and Australia. And scientists are still studying what Steve can teach us about Earth's space environment. Thank you for tuning in to Sparks with Kelly. I'd love to hear more about what sparks your curiosity. Let me know and we may explore it in a future episode. Remember, it only takes a single spark to ignite change. Until next time, keep shining bright.